So let's talk about conservation of mass and energy. First off, what even is the law of conservation of matter? This is a law that states that matter is, you guessed it, conserved. The mass of the reactants on the left side equals the mass of the products on the right side. No mass is lost during the reaction. So we look at it on the left side, we have 4 hydrogens, the gray balls, 1 carbon, the black, 4 oxygens, the red. And on the right side, the product side, we see the same thing. We look for there are 4 hydrogens, 1 carbon, and 4 oxygens. So matter is always conserved in a chemical reaction. We also have a related law called the law of conservation of energy, and it operates in some different principles, but ends up saying the same thing. Energy cannot be lost or destroyed or created, only changed from one form to another. This famous example is the Newton's cradle, which we see on the screen, where the energy of motion is transferred from one end to the next without any apparent motion in the middle. Again, energy is never lost, it's just transferred from one end to the next, right? Energy is conserved. But there's this really funny equation that a guy named Albert Einstein came up with. That's the famous E equals mc squared. And this is relevant to our conversation because it seems to violate this law of conservation. Essentially what it's saying, let me disappear for a minute. What it's saying is that energy is the same as mass times the speed of light squared. And that means they're interconvertible. Energy is the product of mass and the speed of light. And so under certain conditions, for example, in a side of a star, side of a supernova, or atom and hydrogen bombs, mass and energy can be interconverted into one another. C is the speed of light. This is a massive number. That's the 299 million meters per second. So you multiply even a little bit of matter by light, you get a huge amount of energy. This is what makes atom and hydrogen and nuclear weapons so impossibly dangerous. Is a little bit of enriched uranium goes a long way to power an explosion. So in summary, you end up with the same amount of stuff, matter, as you began with, and energy is never created or destroyed, but it does change forms. I mean, again, there are these 2 exceptions, supernovae and atom bombs, where mass and energy change from one to the other, but there's still the total amount of energy and matter is conserved. It's just changing from one to the next. We're not going to worry too much in this course about E equals mc squared and about these nuclear reactions, but just be aware that they are there and they do not violate this law of conservation of matter, as we talked about. All right, and that is it for the conservation of mass and energy. We'll talk more about this in class as you continue your readings. So I will see you guys next time in class.